Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it. Today, graph transformations that win marks.
Hook. This one simple sign error, getting the direction of a horizontal shift wrong, cost more marks than almost any other graph question last year. Students will draw a parabola 2 units the wrong way and lose whole method marks, not because they can't sketch a curve, but because they misread x minus 2. If you've ever felt sure your sketch was right, only to see a red pen mark saying wrong direction, stick with me, because that mistake is easy to fix.
The concept, translations, start simple. If you know y equals x squared is a parabola with its lowest point at the origin. Change it to y equals x minus 2 squared, and every x becomes x minus 2. The graph moves right 2 units. Think of it like sliding the whole curve along the x-axis. Minus 2 moves it right, plus 2 moves it left. Say that again quietly. Inside the brackets, the sign looks backwards, but the shift goes to the right for x minus 2.
Now, reflections. If you change y equals f of x to y equals minus f of x, every y value flips sign. Peaks become dips, dips become peaks. So a maximum at y equals 3 becomes a minimum at y equals minus 3. Verbally picture the curve and imagine turning it over across the x-axis, like flipping a smile into a frown. This matters in exam questions that ask for maximum or minimum values after a transformation. Your description must match the flipped picture.
Stretches and compressions. Y equals 2 f of x scales every y value by 2. If a point on the original graph is 1, 2, on y equals 2 f of x, it becomes 1, 4. That doubles the height of peaks and doubles the depth of valleys. If you have y equals 1/2 f of x, it squashes the graph vertically. Important, a vertical stretch multiplies y values. A horizontal stretch works on x values inside the function and is less common at GCSE, but worth recognizing.
Combining transforms, the order matters for your thinking. Algebraically, operations inside f of x act on x before anything outside changes y. So a rule like y equals negative 2 times x plus 3 squared means start with the base parabola, shift left 3, then stretch vertically by factor 2, then reflect in the x-axis. A handy mental sequence: do horizontal shifts first, then scales on x if present, then vertical stretches or compressions, then reflections and vertical translations last. Say it as shift, scale, flip, then move.
The exam technique, what the examiner wants. For a sketch or description, they usually award method marks for M1, the correct transformed equation, or a correct statement of the transformation. M1, correct plotting or labeling of 1 or 2 key points, and A1, a correct final sketch or final value. So if you can write down the transformed rule and mark 2 points, even an imperfect curve can still collect most marks. 3 common marking mistakes to avoid. 1. The horizontal sign error I mentioned, writing x plus 2 but shifting right. 2. Failing to multiply y values when there's a vertical stretch, so labelled points are wrong. And 3. Not labelling the new vertex or at least one transformed point. Examiners can't award method marks for a correct final shape if you haven't shown the intermediate step or clear points. Write it down, don't just think it.
The quick win, a 60-second sketch checklist you can use under time pressure. Step 1. Identify the base graph: parabola, cubic, reciprocal, line. Step 2. Apply horizontal shifts first. Read signs carefully. Step 3. Do reflections next. Step 4. Apply vertical stretches or compressions, and then vertical translations. Step 5. Mark at least 2 points.
the vertex and one other sensible point. Finally, do a quick algebra check by substituting 1x into your transformed equation to confirm the y value. Quick, reliable and exam-proof.
Before you go to the practice paper, do this, not that rule. Do write the transformed rule on your answer, label the vertex, and show at least one worked point. Don't sketch a curve freehand and hope the examiner interprets it. Marks are there for the taking if you show your method. The examiner wants to see your method.
If you want diagrams, stepwise practice questions and worked solutions, visit jcacademyonline.co.uk. There's a downloadable worksheet linked in the show notes with labelled diagrams for everything we covered today. Practice the 60-second checklist twice before your next timed paper.
Outro and bonus worked example. Run at exam pace. Question. Sketch y equals -2 brackets x plus 1 squared plus 3 and state the vertex. Step 1. Base graph y equals x squared. Step 2. Inside we have x plus 1, so shift left 1. Step 3. Multiply y by -2, so we reflect in the x-axis and stretch vertically by factor 2. Step 4. Add 3 moves the whole graph up 3. So the vertex starts at origin, shift left 1 to -1, 0, then vertical stretch and reflect, leave the vertex's x unchanged but change y by +3. The vertex becomes -1, 3. Label -1, 3 clearly and plot one other point. Pick x equals 0, substitute into y equals -2 brackets 0 plus 1 squared plus 3 gives y equals -2 brackets 1 plus 3 equals 1, so 0, 1 is on the curve. Draw a nice smooth parabola passing through those points, opening down because of the reflection. Examiner-friendly method. Write transformed rule, state shift left 1, reflect in x-axis and vertical stretch 2, translate up 3, then label vertex -1, 3 and point 0, 1. That's exactly how you collect the M1, M1, A1 sequence.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Stay curious. Until next time, trust the process and nail that exam.